So I wanted to talk about a scenario where you would use decorators in a real life application. So anytime you're interacting with any kind of external system, there's a margin for error, and that could be either application related issues or networking issues. So in our code right here, under this function, the get user info function, it's mocking some kind of external call to another system. And given that we're relying on another system, there's always the opportunity for errors to arise. So in this case, I'm randomly throwing a network related issue 50% of the time. And then if a user ID is not found, I'm going to issue an exception saying that the user is not found. So we can note that there are some kind of issues here that we would like to retry and some issues that we would not like to retry. So in a kind of robust scenario, if we face some kind of networking issue, we would like to retry that request at least certain number of times until we get the data that we require, or we finally just conclude we can't hit the service. Something might be wrong with the service, so we just try to do some kind of graceful shutdown. So in this case, if I run this function, depending if we hit the networking issue, we might get some data back, or if I run this function a couple of times, I'll finally get this exception for that simulates some kind of networking issue. So what I would like to do is create a decorator that can retry this function a number of times that we specify, and only to certain type of issues. So this is similar to there's a very popular library called Tenacity that allows to do something very similar, but I wanted to show how simple it is to kind of make your own implementation of that and customize it however you like. So to be able to do our retry function, we're going to start with kind of like a blank slate for a decorator. As I mentioned on a previous video, a decorator is just a function that creates a new function, usually adding extra functionality to the original function. So in this case, we can create something that we'll call in a loop. So we can say while I, and we can say that the I is the current iteration. So let's just start at 0, is less than the max iterations. And let's say we would like to set it to 3. So we at most will retry 3 times, and then we'll just try to return this function. If something happens, if this function throws an error, we would like to catch it. So we would have to wrap this return in a try catch block. So we can do try catch, try except. I'm just gonna catch for exception for starting, and then I could just increase +1. So this means that on any given point, if this fails, the exception is going to get caught. We're going to increase our counter, and then we're going to retry again. So in the case where we have reached our limit, so like if I is currently at max iteration, we would like to re-raise the error. And with that, we're able to have a decorator, simple enough, that should be able to retry our function. So we can add some metadata, knowing to find out when we failed. So we could do function name failed. I could perhaps bring some information about the error, or I could say retrying, put it right here, retrying after this condition, and then I could kind of put where we're at. So I can put the max number of iterations here, and we're currently on iteration I. So we can see now that we try to call it once, we failed. We try to call it twice, we didn't, we failed, and then on the third iteration, we actually succeeded. So if we try multiple times, there will come a time where we'll actually fail all 3 times. If I keep running this, maybe we'll hit it. I can increase the probability of failure to like 95%. And we'll see that we'll retry 1 time, 2 times. I actually want to retry 3 times. So we can do something. We can do So this function got called 1, 2, 3. So this is correct. So this seems correct. We're just gonna change this. Yeah. And then the function will retry 2 times. So actually, I think it'll make more sense if we just do this. Yeah. And then the first run is just a base run for the function. All right, so how can we extend this? So we can have a decorator that's more advanced. For example, we can specify the number of iterations. What's the max iteration? Perhaps we want to sleep between calls. So we can say number of retries is equal to 5. We want to do something like wait, let's say 1 second between calls. And then let's say we also want to support for what exceptions we are catching. So we are retrying. So right now, there's an issue where we're catching for all exceptions, but let's say that we provide a user ID that doesn't exist. It doesn't matter how many times we try this, we are still gonna encounter ourselves with this issue. So it doesn't make sense to retry this error. So I just wanna make sure I save my resources and only invoke this retry on retryable errors. So let's say I want to specify that I only want to retry on networking error. Okay, so how can we support these parameters? In order to support parameters, all we have to do is nest our decorator in an outer retry or outer decorator, or that it's going to support all of our parameters right here, which is going to be number of retries, the waiting time, and the exceptions function. And then this is just a drop-in replacement here for all of our variables here. And then I can time that sleep for this amount of time. I do if wait else 0, or I could just mark it as 0. That should be easier. Let's import the time module, and then exceptions, I can just catch these exceptions. I think this should be able to accept a list. Let's see what we got wrong. Let me change the order, and forgot this retry. Now we don't have a retry. We call it outer retry. Let me just swap these names. Let's just call it inner retry. And then we're saying that a non-object type is not callable, and that is just because I'm not returning this function right here, the inner try. Return inner try. Python 3, let's call it our file, and then catching classes that do not inherit for base exception. That's because I'm accepting a list here, but I can change this to, there we go. So we're seeing that we're trying for these kind of errors, and then if I provide a user ID that doesn't exist, let's say we support 1, 2, and 3. So if we provide 4 and run it, this shouldn't catch the exception because it should go in this order. I should check if the user exists first, and then you'll see that we won't retry the error if it's this issue. If we provide another user that does exist, but we're facing potentially some networking issues, we're going to retry. And then if we change it back to 50%, if we run it, we might see situations where we encounter networking issues and then we retry. And that's how you build kind of a more robust systems with using decorators. And now this decorator, you can easily drop it into other functions that have some kind of retryable error that perhaps calls some external system, and you can make your applications more robust.